through that. Before that, I want to give some background about. Okay, let me share my screen.
Just a quick note, so what I'm saying is, please let's because the details will be able to figure out the details. What we need is really like the high level. For example, if you can go to the project, breakdown of the different parts of it, because it's not really clear the way it is organized, and it's changing, and it was actually, and it's changed. So we need to get that information mostly.
Okay. So first of all, I want to share that.
Okay.
No, we haven't changed that any interface till now. Okay, and no, we haven't modified that any interfaces till now. Only thing is like we put only the deprecation. It means like we are going to follow that already. If you look into the Casablanca release itself, the Spring, we started using the Spring Boot 2 version. Okay, now the Spring Boot, they have released the 2.1.1 version. Okay, so it means like, and they removed that support for MVC if you are trying to use a WebFlex. So you can't use that both WebFlex and Spring MVC. So from 5.1.1. So when we migrated that Spring Boot version from 5.1.0 to 5.0.2, that is a Spring version 5. If you consider the Spring Boot version like a 2.0 to 2.1, then we must use either WebFlex or Spring MVC. Okay, so and going forward, they are going to support the WebFlex completely. So that's the reason. So we are in a position to take a WebFlex support completely altogether. So that is the reason. If you look at the last two version, okay, which is already in our Git repository, Onam Git repository. So we already have, and we already migrated that version also from both the Spring Boot and the Spring versions. Okay, Spring Boot version 2.1.1, I believe, and then Spring version 5.1.3, I believe. Okay, so even you can get that information from here itself. So that's where. So we are in a position to remove that Spring MVC. So one good example, it's like if you look at the Swagger UI and all those implementations. So we had it in MVC, okay, Spring Boot and MVC, and even the base of all our modules, we had it in Spring MVC. Okay, so what we have done, and even the cars. Okay, I believe that whatever I'm trying to speak, I think you guys are aware of that. Just to stop me if you don't get that information what I'm trying to speak. Okay, so cars, all those definition. Okay, it's like just we are in position to migrate that to Spring reactive. Okay, reactive support. So that's the reason if you could see that last two versions before that, I migrated that enable WebFlex. Okay, so if you want, I can share that. Okay, so you could see that enable WebFlex. Okay, this is that version that we migrated Maven, and then we removed the Swagger, deprecated the Swagger, and web filters, modified the web filters, and modified the costs, and modified the security authentications. Okay, and all those stuff that we made, because we are in position to migrate to the Spring version. Okay, because of the Spring version, right? You could see that it is from 0.6 to 2.1, and then 5.0 to 5.1 version. That's the reason. Okay, and other than that,
just a quick question. So was that move to WebFlex mandatory, or we could have stayed with MVC?
Or no, it's like you can't use both. That's a problem.
Okay, but we couldn't stick with just MVC.
No, MVC is not performance oriented, and even the Spring Boot also it is not going to work in MVC pattern in future. So completely.
Okay, perfect. Fair enough. Excellent. Thank you.
Okay. So if you want, you can get that what is new in Spring 5.1. I think you will get that lot of information. Okay, in Google itself, and for Spring Boot 1.1, you can get it. Okay. So so that is the reason. So we have duplicated that so many functionalities. Okay, which is a Swagger functionality, whatever we have, and then security, cars, okay, and authentications, most of the things. Okay, so we have deprecated that. So along with that, okay, along with that, this APIs also we want to deprecate that. Why? Because all those APIs are it's MVC pattern API, so we want to go with WebFlex APIs. Okay, that's the reason. And in 5.1.1 or Spring Boot 2.1.1, they have the two ways actually, okay, to implement the REST API. One is through routers, okay, and another one is through that REST controller annotation based. Okay, two ways, okay, to build that APIs. Okay, right now we are keeping that same in order to have a minimal code impact. So we are not going to remove that REST annotation based kind of architecture. Okay, annotation, it means like a still REST controller we are going to retain for some more time. And after, if we feel that if the performance is not good, okay, then we are going to move to that router based kind of support. Okay, so if you need more information, so I think you can go and look into that Spring documentation. So you will get that how to implement that APIs, how to implement that REST. Okay, so that is so that's the reason. So I put that only the deprecated, until now not even single module. So that's the reason you could look into that. Okay, all the codes whatever we have, okay, only the deprecation. It means like just I annotated that. That's it. It means like there is a you guys can expect a change there in the particular file, right? Okay. Now coming back to that. Okay, I think I answered all my what to say. All the words commented me on just modified the code at a last moment or without informing, right? Okay. Yeah. Now I think we can start from the design perspective. Okay. Before jumping into that design, so you have any other you need any clarification with respect to that?
No, this person is perfect. Maybe I don't know what would be the best if you could just okay. So now this is deprecated because in the future we're kind of moving away from the interface and we're going to the new interface. So maybe if you can just shed some light on the structure of the code of the existing current code. How that will be like, but just remain high level, like.
Exactly.
Let's get into the details of like Tosca or that. That we're going to cover in the next phases. As we're comfortable with the current code structure.
Sure. Okay. Now I'm going to talk about that structure. Okay, what structure that we have, and with respect to that use case, and I will talk about what all the modifications that we want to do in your side. Okay, is that expectation, right? I believe that is the expectation of this call. Yes, I'm going to do that.
Yes, exactly. Yes, please. Thank you.
Sure. And see here, so we have, I think, let me go to that project. Okay, so okay, we are using on master branch. Okay, so master branch we have that, and this is a CCSTK apps. This is the main project that we have, and we have components. Okay, components are reusable utility modules actually. Okay, so it's suppose if you feel that particular module is common for both or multiple microservices. Okay, if it is common for more than one microservices, okay, that we are not going to pack inside the microservice. So we are going to have as an utility, and we are going to provide that utility, all those utilities inside the component directly. Okay, so finally the end result will be the jar file, the output of this jar file. And
okay, so for example, like a question, like let's say if you have like a compression, decompression, file management should go in that section.
Yeah, exactly. So utility file, one is utility file, and one is which you can think about a reusable perspective. Okay, not one microservice. Think about like we are trying to create two different microservices, one for designer and one for configurator, okay, so one for runtime. So that blueprint, okay, that validation logic should be same, okay, even from designer perspective also, runtime's perspective also, it is going to same. Some extra information will be added there, so that validation will be a common as far as me, okay, and parsing cap blueprint parser, right? So that blueprint parser also, it's a common logic, okay, so it's like between the two, and even reading that blueprint and writing the blueprint, okay, that logic also it is the same, okay, even from a controller designer perspective also, or so the runtime perspective also. So whatever you feel, okay, that is a reuse perspective between multiple microservices, okay. In our case, we are going to have only 2 microservices for right now, okay. So if you feel that if it is a good and reusable for both the environments, then move it to that component layer and inherit that component layer, or make a dependency of that component layer to the both the microservices. Okay, that's where we have that. Okay, so if you look into that, the main core components, okay, that we have, it's a core and a resource dictionary. Okay, both are okay Java based or archive based kind of solution. And model catalog, it's more of definition information. So it's like where we store that blueprint models, okay, and a dictionary definition type where we have that node types and all those reusable node types definition, that we have it in definition type. And resource dictionary, okay, it's like a dictionary, data dictionary or resource dictionary, okay, reusable data dictionary.
So it's like metadata, right, Brinda, with model catalog?
It's a more like, no, it's a package actually. Okay, think about right. So we want to have a blueprint, and which should be a version controlled actually. Okay, because we want to track, okay, what are the modifications done on that particular file that we deliver, or that it has to whether if it is going to production. So it means like someone should not tamper that, and then we should keep track of what all the modifications are done on a particular service-based or controller service-based models actually. So that's the reason. So we are keeping a directory location so that we are having that model catalog as a file structure. So here, whenever there is a change on a particular service, okay, if you look into the blueprint models, so we have a startup blueprint and service-specific blueprints, okay. So if you want to create a firewall, okay, so that's the reason firewall blueprints are available here. And later point of time, if you are trying to create a new ADK, other services, okay, so then you can create the folder structure and place the blueprint here so that it will be tracked. So it means like we will come to know that who modified that, and then what changes that we are trying to make, and it also once again gives the confidence like it is certified with other security vulnerability. Okay, so that's the reason we are trying to version control that blueprints, okay, in this directory structure. Finally, what happens? Okay, let me talk about the later point of time, how it loads to that designer time, and how we can make use of that. Later I will talk about. But just to keep track of blueprint definitions, node type, reusable node type definitions, reusable dictionary definitions, then we have a model catalog. Okay, so in order to keep track of that, and other than that, we have a scripts also. Okay, so we are building a framework. Okay, it's like execution framework. Okay, so it means like, and we are going to support for a lot of scripting functionality. Okay, so for such as a Python, Kotlin, and even later point of time, if different languages comes into picture, then we are going to support a scripting functionality. Okay, so that's the reason. So we have a script folder, and then script folder holds that reusable or framework related, wrapper related content. Okay, so that's the reason. So in order to call Jython scripts, okay, we need to have some wrappers, okay, around that. So that's the reason. So it's a Python based, okay, scripts we are keeping that. Okay, if you want to have a JavaScript something like that, then you can have a JavaScript based scripts reusable. It's a framework related scripts. Okay, so we are going to keep that. So that is the structure. So these two, core and resource dictionary, okay, two different modules, okay, and we don't want to club that core and resource dictionary. Why? Because core is a pure Tasca-based kind of definition, and resource dictionary is a add-on package. It's not part of the core. Okay, it is an add-on package, and some organization may need a core only. Some organization may need both. Okay, that's the reason we separated out core and resource dictionaries. Okay. Resource dictionary mainly to resolve that resources on fly, or model-driven way we can resolve that resources using that resource dictionary. So that's the purpose. We have the two different modules. Okay. Let me move on to that microservice. Okay. So we have components, and then okay, we have a microservice, right? So components is a reusable structure. Under this microservice, with respect to CDS, okay, we may use that multiple microservices, but mostly we are trying to concentrate on these two things. Actually, it's like a model-driven platform. Only these two things. Okay. So one is a controller blueprint, which is nothing but a designer controller blueprint, and the blueprint processor, it's nothing but a runtime microservice. Those are two things. Okay, we have that. Okay, and this is a multi-modal.
Quick question, Brinda. Sorry to interrupt. So, for example, like the database access, that you would put also in the common part, right?
No, database.
Or you put it in microservice as well?
Yeah, it's a part of microservice, right?
Okay.
Okay, database, it's not a common, because designer may use a different database and runtime may use a different database, and these two platforms, it's not same. Okay, so some system may have only the designer, but they don't have the runtime itself. So it means like the database, it's completely different, and each one has its specific scope. Okay, it is not going to be the same functionality to satisfy all. Okay, certain things may be a common, but most other things, it may not be a common. Okay. Yeah. Now, just I'm going to take this structure in editor. So I'm coming back to the editor. Okay. So I kept only those information. So it's what related to that. Okay. CDS that I kept here. Okay. Under the components, we have a core, model catalog, and then scripts, and then resource directory. Okay. It's a parent. It's nothing but a parent BOM file, which tells that what all the dependencies that we have and the dependency management that we are trying to do it with this parent BOM. Okay, so you could see that all the versions are here, and if there is always we are strict to that latest version, latest stable version. We are always strict to that. So we are going to do, if we feel that if it is a stable versions and already available, then we are going to change automatically. So all organizations should be aware of the changes and then latest one. Okay. Now, coming forward, the core. Okay, let me talk about the core, and later we can talk about other stuffs later. So under the core, okay, we have these are all the high-level packages. We have a core, and where we have a blueprint types. Okay, and okay, let me talk about the blueprint data first. Actually, okay, so here is the blueprint data. We have a blueprint model. Okay, this is a version, it's related to that Tasca version 1.2. Okay, and if you feel that if there is any changes in future also, then we are going to add the Tasca changes. Okay, version 1.2. We are going to include those definitions here. Okay, so I think you can refer that, and I'm repeating that. Okay, we are not using 100% of a Tasca definition. What is required for our case that we are trying to use that. Okay, we are not using all the Tasca definitions because it is not relevant for our case. That's the reason we are using only node type, node templates, and certain informations like artifact types and artifacts. Okay, and then properties, interfaces, operations. Okay, workflows. Okay, you could see that what all the definitions that we are using. And you could see the annotations and the descriptions at the top, so that you can refer back to that Tasca site to get that information. Okay. And so this is the model that we are going to use on high level. This is the model that we are going to use. We are going to represent that. And then coming back to that other informations, we have a constant file, so where we could see that all the constants that we are trying to refer. Okay, so if you look into that, these are all the constants files. Okay, you could see that. And some of the types that we are supporting, that some of the artifacts types and node types. Okay, some of the Tasca defined informations that we are relationship type and all those things. So you could see that In this file itself, you will come to know that what are the types that we are supporting and what are the relationships that we are supporting and what are the scripts that we are supporting on all those most of the information you could get back in this file. Okay, and along with that, okay, we have a type file. Okay, this is the type file. Okay, just for validated perspective. So you could see that, okay, each type validation, what are the model related validation, okay. If an example, valid node types, okay, what are the valid node types that we have? Okay, you could see that all valid node types, okay, and then valid artifact types that we have, you could see that, and then relationship and all those things, okay, you could see that in definitions, okay. It's a utility to get that validation information, okay. Other than that, you know that these are all exceptions, okay. One is a normal exception, blueprint exception, okay, which is used for design time, and blueprint processor exceptions whenever we are dealing with that processing that if you get a failure, then you are trying to use a blueprint processor expression. And validation error, we are not using that much, okay. A later point, okay, we can integrate that validation error, okay. Right now the definition is there. Okay, to hold multiple validation errors. Okay, so for that we are having that, and this is not needed. In future we are going to remove that. Okay, this came along with the part of publishing. Okay, when AT&T started upstreaming that models, so in order to have a minimal impact, so we modified or we sent we pushed this file itself. And most of the constants we already pushed it to that constants file. Okay, so going forward later point of time, this may not be available. Okay, and custom functions. Okay, Kotlin has a very good feature. Okay, it means like for a particular class, if you define a class, then you can attach extra functions to your particular class. Say for an example, I have a string, and then that string is a class, Java class, and then I want to get as a JSON primitive. So it's a JSON, we are using a Jackson. Jackson is good right now, but there are some security vulnerability with respect to Jackson. In future, we are planning to move towards some other framework, which is a reactive or which is a stream-based JSON parsing. Okay, it's like a not a static content. JSON is not a valid fit here, because that is not a reactive-based or stream-based parsing. So Kotlin is coming up with its own serializer and deserializer. So later point of time, you may expect the changes, but not now. Okay, so we are using a Jackson. So that's the reason you could see the Jackson definitions are here. Okay, you could see the definition. And similarly, you can override that all the functions. Okay, simple one.
Brinda, just a quick question. So the purpose of the custom module, I'm sorry, I didn't get, like what you said, that this is for what can we customize here?
Okay. Think about like you have a string class. Okay, string class, it has only 2 string. Okay, suppose if I want to attach one method on a string class. Okay, so it means like, let me go to that. Okay, so you have a string class, so it has only right for a.
Oh, okay, I see.
Kotlin provides extra functionality. Okay, so which is very useful. Think about like the scenario. I want to work in a functional way. Okay, if I want to work it in a functional way, so if I want to have an extra method, then I want to create an extra utility, and I want to pass that extra utility inside this class, and then I want to do that operation. But Kotlin has a very good framework, so that's the reason. So I can add any functions, attach any functions along with it.
Okay.
So that I can work it in a more functional way. Like I will show that at a later point how we are trying to use. Okay. And then similarly for integer boolean, I attach that because the string is this one, and JSON representation we want to do that. So that's the reason we have that framework. And another good thing is like a format and map. Okay, think about like a map casting. Okay, so if you want to get a value from that map, so by default you will get an object. Okay, you want to cast that value into another object. So it's like each and every time it's like a problem for me. I want to write extra code for that. So I have overridden that map functionality which casts optional value and mandatory value. So we have overridden that so that automatically we can pass the type, which type that we want to convert, then automatically it converts that. So similarly, like getting a JSON object and putting a JSON object back. So And another good example, it's like a to file input stream to file, and we don't have the functionality. So what I have done, I overridden that input stream to file functionality there. Then automatically, if we have an input stream, then automatically to file you can also convert. Okay, so like that you can write your own custom files if you feel that. Okay, if there is any necessary for any of that utility to be there. That's the reason we have a custom function. And yeah, that's all with the core, main core. And factory. Okay, factory. Leave about that factory. Since we started using that Spring, I think we don't need the factory. So if you're planning to use only this core module alone separately, then you can make use of a factory and have implementation for that. So that in that case it will be helpful. But other than that, it is nowhere we are using. If you are using a Spring, I think you don't need that. Okay, this factory. Okay, and
because the factory, the purpose of the factory was to create an instance of like a blueprint parser, or
yeah, no, you can register that any instance of a particular type. Okay, validation file. You can register that with the key names, and we can get that instance, get those instances. Okay. Say for an example, you may have a number of validation implementations. One is a default implementation, one is maybe a custom 1, custom 2. You can register it during that startup, and then you can retrieve those instances during the runtime anywhere by just passing that key. That's the reason. So it's like a framework
okay.
to register and retrieve. Yeah, that's the factory. Yeah.
Okay.
Okay, and coming back to that, but Spring supports the by default with the service annotation and the component annotation. I think we don't need this validation factory, so that we can dynamically get those information using that name, any point name at anywhere in our file or anywhere in our class. That's the reason. So we don't have that. Okay, and coming back to another, it's interfaces. So we have interfaces. Okay, so one is validation. Okay, just let me talk about that validation. Okay, so you know that we are using multiple different task card definitions. Okay, so one is node type, node template, data type, okay, and then one artifact, workflow, property definition, property. So many types that we are using that, and there may be a situation where for a particular artifact type I want to do a different validation. For a different type, I want to do a different validation. So in that case, what we need a framework, or we need an architecture, okay, where I can register my validation, okay, anywhere in the class, not only on my module, on my extra module, I can add it and then inject it during my runtime. So that's the reason. So we have pluggable architectures for validation. So we have a blueprint validator as a high level, and which is a common validate function, which takes a blueprint context information and blueprint validation error, okay, just to cascade that errors. Okay, so we have that, and then type, okay, name of that particular validation definition, name, and then type. Okay, this type denotes that what is the node type or definition type. So this is a base blueprint validator, and then we have a blueprint validator for service template, topology, artifacts, okay, data types, node types. Okay, you could see that this is a extended interface. Okay, we have extended interface there. Okay, and this is about a blueprint validation interface, and then we have a validation service. Okay, we have a blueprint validation service, and then blueprint type validation service is the main validation service where you can implement the service. Okay, on a top high level. This is at a high level. Okay, so you will have only blueprint information and some property keys if you want to pass any arguments, okay, or any reference information, then you can pass inside the key into the property, so that you can make use of those properties. Okay, and this is a blueprint validation service and blueprint type validation service. It means like this is the one which automatically retrieves that, okay, what all the validator registered actually. Okay, if you look into that, see here, get data type. So you have a blueprint data type validator. Okay, list of blueprint validator. Okay, it's nothing but, say for an example, I want to have a 2 data types validator. So I can have a 2 data type validator, and if I annotate automatically, if I annotate those 2 validators, and this method will retrieve 2 validators completely. Okay, so that is the reason for we have that. And finally, during that validation, so this validator returns that and do validation. So what it is trying to do, it is trying to iterate. Do validation is nothing but it is trying to iterate and then validate that information. It is nothing but if you register at 10 validators, then automatically 10 validation, each one will be executed. Okay? So that's this is the architecture. So only this implementation, okay, that lookup it's going to change because this is a core framework. Some may use a Spring in their actual environment. Okay, some may use a different Dagger or a different dependency management system. So that's the reason it is kept as an open interface. So whoever wants to implement that, they can implement this interface just by, if it is a Spring, then you can look for application context. What are all the registered Spring Beans, then you can use that, or else you can manually inject that also. So this is that interface about. Now, any clarification needed for that in this blueprint validation type service?
No, it makes sense. Very good. Thank you.
And coming back to that blueprint function, you all know that we are going to create all those as a component. Okay, in a directed graph, each node is a component, right? It is not like a simple execute node. It is going to be a component. So which serves a dual purpose. One is it can be part of the flow, and as well as it can be invoked. It can be invoked separately also, so as a REST or any other mechanism. Okay, that those components can be. So we want to keep it in mind that that component has a. It should be first thing. It's it should be as mostly we want to avoid as a make it as a stateless kind of thing, so that it can participate in an individual chain. Okay, and sometimes you may end up participating in terms of in a flow also. So that's the reason. So we component function. Okay, so it has an input and output. So it has a separate information. So it has a separate functionality. So one is a prepare request, one is a process, and recover. Okay, process is nothing but real business logic goes here. This process implementation. And a recover, if there is any failure in that process, then you want to, it is our duty to recover that. Okay, it means like cleanup. Okay, cleaning up the data, whatever inserted during the process. And then if you want to, you finally end of the day, you want to make it that particular component as a retriggerable. Okay, so that's ultimate aim. Okay, so you want to implement a recover function. And finally prepare that response so that it can return that response back to that. So this is a functional node. Okay, so based on that, what kind of implementation? If you are trying to implement a component function, then you can extend this. Or if you are trying to build a blueprint service function, then you can do it. Or if you are trying to build a resource resolution function, you can extend it and define its own nature. Okay, so each places you can extend this and have it as a own nature. So since it is a reusable across all different modules, okay, so we are defining as a blueprint function node. Okay. Next, coming back to
Rita, can I suggest something? Would it be possible if you could just shed some light on how because this is actually when someone basically stores the blueprint, right? And then we're trying to actually execute like the assignment based on that blueprint, right?
Yeah,
exactly. For example, right? So would it be possible at some point maybe you can just skip a little bit the details, but just go like how this process is triggered, like where do we go, like okay, let's say we can start, for example, it's in the database or and then it's triggered by one of the requests on the runtime, for example, right? And then we how does it start? Because after like the actual process, we can probably walk through that somehow to some certain extent, right? And
okay, I think that is the case. Then I want to jump from that flow. Okay, then let me jump. Mm-hmm. Okay, so assume that you have already prepared a blueprint. Okay, the blueprint CBA file consists of a plan. Okay, one is a directed graph. Already you have a directed graph for that each action. And then you have that component implementations already registered in your environment. Okay, assume that you have two different functions. One is the resource resolutions and a simple Python executor executing a Python script. Whatever. Assume that you have that. Okay, So whenever you are trying to implement a function, or if you are trying to implement a function, then the first step it's like you want to define a component function. Okay, so if you look into the component function, so this is a component function, and which always extends that abstract interface, which is nothing but a blueprint function node. Okay, you could see that blueprint function node. Okay, so that is nothing but this one. Okay, what is defined here? Okay, so it means like when this component first it has to implement that particular function, so that you will have this business logic of okay, you can implement the business logic here and recover. So only your duty is to implement that business logic here. Okay, now how it is invoked in a chain or invoked, so that comes, it's like that comes a workflow executor. Okay, if you look into that, we have a workflow executor. Assume that before that, let me show that model actually. Okay, so that you can understand that what it is actually. Okay, we have a model catalog and we have a blueprint, and under that this is one sample blueprint. Okay, so blueprint consists of a definition, plan, script, templates, and definitions. Okay. Under the definitions, you have the main blueprint definition file. Okay, this is a blueprint definition file. Okay, here you have that concept called workflow. Okay, workflow model. That workflow model here you are trying to define that. Okay, this is one workflow. Okay, workflow is a list, right? So you can define a number of workflows in our under the workflow definitions. This is another workflow. Activate is another workflow. And assign and activate is another workflow. So total 3 workflows are there. Okay, in this process. So we have 3 different workflows, and then if you look into that, we have a step. Okay, workflow has a multiple steps. Okay, and for right now we are defining all these steps in a directed graph. So that is the reason you could see always only one step, even if you are trying to orchestrate 2 different components or 3 different components. Okay, you are having only one step, and in this case, okay, so you are referring that that first step, okay, to the target of resource assignment process. Okay, resource assignment process is nothing but another node template instance of DG instance. Okay, so we have resource assignment process, okay, node template, okay, which is of type DG activate, which is nothing but generic name, okay, generic DG. Okay. So this denotes that this node template is a DG type, okay, and that DG type definition you could see it in the plan resource assignment config, okay, under the definitions of content. Okay, under the content you have a get artifact expression, okay, get artifact expression with of self and DG resource assignment process. So it is nothing but it looks for that artifact definition for DG resource assignment process. In that it is linked with that file called plan, this one. Okay, so automatically it looks for the plan, and then plan has a config resource assignment. So this is nothing but directed graph. Okay, with that DG builder we are trying to build this directed graph. Okay, this directed graph has a execute node. Okay, execute node, this is nothing but a component. Okay, so here plugin, you could see that plugin, which is nothing but DG directed graph markup. Okay, you could see that all those things are directed graph markup. Okay, so here this denotes that component actually. Okay, what are the plugin you are trying to mention? Okay, that denotes the component. That component is nothing but node template definition, right?
Okay, so this is sorry, this is another it's a template definition. Okay, so it's contained in the template subdirectory, right?
Yeah.
Okay. So if we just backtrack, so what happens that we have let's say the blueprint that refers, it refers to a DG, right? I mean, first of all, there's steps in the blueprint before even actually getting to the DG, right? So here, the first step, like if we go here, it's what resource assignment workflow. So basically, here we're going to trigger. It's going to be a resource assignment. The resource assignment process that is it's not a DG yet, right? This is
let me talk about that. Whenever you get a request, okay, that request contains blueprint name, version, and workflow. Okay, which workflow I want to kick off. Okay, in that request. Okay, so one sample I could show that. Okay, this is one test. Okay, this is one sample, right? So this is a request, okay, in a blueprint processing platform. So you have a common header, you have action identifier. This action identifier identifies that, okay, what? So it talks that blueprint name, it has a blueprint version, and it has that action. Okay, this action is nothing but workflow action. Okay, so here we have, okay, so activate this one, then by default it will go and look for that assign and activate. Okay, so it looks for that assign and activate.
Okay.
And
Okay. This is very, very good, actually. Thank you for this information.
okay, and it looks for that okay, step one, because we are using a DG. Okay, so it looks for the step one, first step activity, or first step target. Okay, the first step target is assign activate process. Okay, assign and activate process is nothing but, okay, it looks for that assign and activate process, which is nothing but directed graph. It looks for that file content of assign and activate. Okay, now that assign and activate, okay, we have assign and activate netconf. So it executes this service logic, right?
Okay.
Okay, now whenever it executes that, it looks for that first block. Okay, first block, it's nothing but it has to call a resource assignment block. Okay, so where this resource assignment definition, that is also in this same template. Okay, so you could see that.
Okay, it goes back to the okay.
Okay, so you could see the resource assignment. That is a component. If you look at component, right? Plugin is a component, so it looks for that resource assignment node template. That is nothing but a component resource assignment. Okay, that is nothing but the function here. Okay, component.
Okay, so all those different, like if you just go 1 second, go back to the blueprint file that you were like 1 second ago, like just previously.
Yeah.
Okay, you see, it says resource assignment. There's a type, right? So, okay, each type corresponds to a specific class.
Yeah, specific function.
Okay.
Yeah, that is a function. That is an abstract function.
Okay, in service resolution, in the service resolution package. Okay.
Okay. Similarly, let me show.
Okay. I see. Okay, this is good. This is very, very good.
Okay, so let me show that other representation of this. Okay, so we have another component called component. Okay, this is also component. Yeah, we have another component called component Jython executor. Okay. This is of type. So where we have Python executor.
Okay.
Then we have a component, and then we have a component Python executor. Okay, which is nothing but which inherits that abstract component function. You could see that. Okay, both it inherits that abstract component function, which is nothing but blueprint component function, which implements the blueprint function node, right? Okay. I think you guys are clear now how it.
Yeah. Oh yeah, this is amazing. You know what? I think we should, maybe if many more people, join to this project, have, some sessions like this, like a few hours, maybe, spread over several weeks or something, just to share this information, because, I mean, it's very easy if you come from, that you have a very good knowledge of Tosca and how things are kind of related in Tosca, then this is kind of pretty straightforward to understand, right? But for, someone who's kind of new into this, right, it's extremely abstract, so we cannot, we don't understand really how to navigate through this, As soon as we understand navigation, everything else is becoming trivial, because this is just code, right? You can read code.
So in that way, it denotes it makes a reference, and then we have a executor. Okay, so we have that executor, workflow executor. If you look into that directed graph executor, we have a directed graph executor. That executor, okay, you could see that first it is trying to understand that, yeah, whatever the steps I have explained right now, that is in code. Okay, so it understands that workflow name, and it understands that okay, first step. Okay, you could see that it understands the first step, and then automatically it takes that artifact definitions of that particular first node. Okay, target, that is a target. Then it takes the file, where exactly that file content, that executed the directory graph file content, then it prepares that instance of the file content. First, it creates a context, okay, input context, okay, it creates an input context, and then, okay, it is trying to execute that, okay, you could see that, it is trying to execute that blueprint.
Okay.
So this graph is executed by passing the blueprint runtime and execution input, okay.
Okay, and when the output is like the like the outcome of the resource resolution or resource accumulation, where is it where does it appear?
So that you want to implement, that is the output of this function. So during that implementation, you will set that output, okay, whatever defined in that definition. Okay, so you have to, okay, because once you are trying to define a model, okay, once you are trying to define a model, so that these are all the response your component is returning, right? So your component is returning this model, okay, this response, right? So like that input, you have that response, okay, input. So
Okay.
inside the component, you want to set that property values, okay, you want to set the value for this particular component, okay. So once you design a component, it means then you are modeling that component, then you should know that what is the input and what is the output, right? So that,
Okay.
then you are trying to model that, right?
Okay. Okay.
Yeah, I pass here to take some questions. If any.
Yeah, actually, okay, good. Please go ahead. It's okay. It's perfect. Yeah. We okay. We have half an hour. Okay, you're good for half an hour, right? That's no problem, right?
Okay, so now coming back to that core module.
Oh yeah, I wanted to ask you one thing because you see, like we looked at this; those are like the blueprints, right? In that directory where we have the definitions, the the metadata, etc. Right? But this is so the blueprints they come from design, right? And they're stored in the system database. Now, when like an action wants to be performed in the runtime, right? And then we're talking about not anymore about blueprints, but we're talking about models, right?
Yeah. We are,
okay, so
now we are talking about only the execution of the blueprint only, but
okay,
preparation, everything, it's not implemented. So that is like, I think individual owner has its own task to do that.
I'm sorry, I didn't get that.
What is your question exactly? Just
no, because I'm just saying that like okay, so we just went through like the blueprint, right? So the blueprint as it's kind of defined in the design, etc. Right? And so like how would you showed us the request that triggers the specific action, right? That in that there was this little JSON basically, which is I guess received through a REST interface that kind of triggers that process, right? And the process triggers like DGs. It does many things, right? And there's different classes involved, different blueprints involved in this. But when we talk about like models, right? Because a model is I'm a little bit confused here about so during the runtime, we just need to issue that REST request, right? And that has all the information with the blueprints to perform everything that it has to do.
Yeah, exactly. Okay, so
there's no other like element or artifacts or anything else that is required in order to, for example, assign service.
Nothing. Okay, assume that. Okay, if you look at the process of this flow, entire CDS itself. Okay, first user designs the blueprint. Okay, so user creates a blueprint first. Okay, that blueprint, okay, along with that, whatever the component, existing component model, and what orchestration he has to perform. So with that knowledge, okay, first that user builds that blueprint model, and he will create a CBA file, and this file will be distributed to that runtime environment, either from directly or either from ASDC. Okay, it can take any channel. But the final goal, it's like the assumption, it's like that controller blueprint archive file, it is stored in a blueprint runtime server. Okay, that is the assumption. That is the assumption in the database. Okay. You are getting it, right? So
yes, absolutely, yes.
Either someone is uploading that CBA file to the runtime, or it is coming from ASDC. Okay, right now that is not the discussion. The discussion is like whatever the controller design CBA file designed in a designer, that is controller blueprint, UI as well as a microservice. So that is available in a background in the runtime platform. Now you are trying to get only the request for the particular blueprint with inputs. Okay, for the particular blueprint inputs, you are getting a request. So blueprint runtime, what it takes first, after receiving that request, after getting that request, okay, it has to download that CBA file from the database, okay, and then it has to execute, right? So, the download capability we want to implement, we need to include, we need to have that users to, we need to implement, okay. That download, it's nothing but prepare the blueprint, okay, preparing the blueprint for execution. Okay, that is the interface, right? So that interface we are going to have with that interface. What we are going to do, we are going to implement inside that, okay, downloading from the database and extracting that CBA file in a certain path, in a file path. Okay. Now the blueprint is ready for execution. Now it is downloaded from the database. It is available in a file path. Now based on that request, okay, it is going to execute. It is going to create a runtime service, okay, with that for the specific path and for the specific request. It is going to create a runtime service, and then it is going to perform that action based on that input, whatever it comes.
Okay, so because you see, the way we're seeing this is that the CBA files would be directly stored in like database, but not in a CBA format. The CBA format to me is just a zip of the directory that you showed us earlier, right? And that's how I was kind of seeing it, right? And so upon receiving a upload request for a specific CBA file, what we were doing, I mean, so far, right, we were actually aligned with the Casablanca features, right? So we did not add anything or we did not modify any database. We're just using those two tables, one for the blueprints and another one for the models. And so we would receive it, that's how we implemented it so far, right? And we would extract this. We would, walk through the directory that we got from the extraction and find, the definitions, which were referred to as the actual blueprints, the templates, right, and the metadata, and we would store each of those components in the database. Right? That's how we're seeing it. But now I seem to understand that the CBA should be stored in the zip files, really, and only whenever we need to use a specific blueprint, right? Only when we need to use. I mean, they're already stored in the runtime as zip files, right? Yeah. And then only when we need it, this is when we actually. So, for example, the choice here would be probably to use something like MongoDB or like a file store, because those are files, right? And then we extract it, right? And only then we actually read it. But the blueprints are never stored in a database anymore, right?
No. By default, all the blueprints will be stored in a database as a zip format. Okay.
But in a zip format? Okay.
Yeah, in a zip binary format in a database.
Yes. Okay, that's good. Until I'm 100% with you. Yes.
Okay. Now you are okay with that at this point. Okay. So now all the CBA files, it is nothing but the base configuration.zip. Okay, it will be stored in a database. Okay?
Yes.
Okay.
That's right.
Okay, and during that execution, what it happens? Okay, you are storing in a database means just you are making annotation for that. So it means like you have a record for, or you have a column for what is the name of the blueprint and what is the version, and finally that content is a binary content. You will store it as a zip.
That's right.
Whenever you get a request in the runtime platform, okay, so I can't operate on zip file. So I need to first.
Of course.
I want to look all the files, what all the content present inside that. Okay. So as a first step, what I will do, I will download that zip file from the database and keep it in a some path, right?
That's right.
In a some path, right? File structure.
Yes, but so that would be like a staging area, and that's not the intention of this is not to be forever, only during the execution, right? And then after the execution, we should remove that.
Yeah, we should remove that. Okay.
Okay. Very good. Yes.
You are getting it. Okay. We
Yes.
should remove it, or we should keep for a certain amount of time, because now if you are getting a request, the same request for same blueprints, then we don't want each and every
Of
time
course. Of
want to
course.
go and download from the database. Okay. In terms of performance.
Caching system. Yeah.
So this is the concept, okay? That concept, okay, even for blueprint extraction and keep it in a path, it is a common functionality for both runtime as well as the design time also. For design time, in order to do a validation, okay, we need to do a validation, right? So in order to do a validation on the blueprint, we need to extract that content and place it in somewhere. Okay,
That's
that
right.
is from designer perspective, designer microservice perspective.
Yes.
But in a runtime perspective, okay, we need to download from the database and then extract and place it in a folder structure. Going to execute the blueprint, okay. That we have a multiple purpose, but the functionality is the same. So it means like blueprint is already stored in a database in both the environments, okay. So even from design time also, it is stored in a it will be stored in a it will be stored, or you will try to get it from input, okay. From
Okay. So basically, this means that there's two databases. One in the design, one in runtime, and both. Would you like to have both in both actually storing the binary format?
Yeah, exactly. Yeah.
Oh, okay. Because shouldn't we instead have like only per blueprint, shouldn't we have only one database entry? Let's say either design and then, okay, no, because it has to be, I'm just trying to, I'm kind of thinking it out. Okay. No, because if we have like duplications, and if it's like supposed to be the same blueprint.
So it is not. It is not the case, right? Okay. So designer, I may have 100 blueprints, but from runtime, I may need one. It's a service-specific runtime. I may have that. Designer, I may have 10. Okay, but for runtime, I may have a one. Design time I may have a one, but runtime with respect to each service I may have that. So in that case, and moreover, we are working on controller, right? So it's a storing that blueprint in a design time. It's optional. Okay, either it may come from ASDC, okay, or else we can manually upload to that runtime directly. Okay, so it means like that without designer also it is possible to have only that execution environment. So it means like the purpose is different, but the functionality we need it both here and there.
Okay. I understand what you mean. Okay, I understand, of course, because in the designer, basically, it's just a way to save it, right?
Yeah.
For future edition, and for real time, it's to save it for execution. Really.
Exactly.
Yeah. Okay. Perfect. So basically, this functionality should be actually we should create one single functionality for uploading it and storing it in a database. And downloading and indexing, etc. Okay, for both basically, for runtime and design. Okay, so we're going. You know what? So we're going to focus on that functionality in the immediate. Okay, but please go on. It's very, very good actually. Now I finally understand. Yeah.
Okay. So I have created one interface for that actually. Let me show that interface also so that you can make use of that interface to implement that functionality. Okay. So here we have. Okay, blueprint catalog. Okay, just I name it as a blueprint catalog. Okay, that catalog prepare blueprint. It's implementation basically. Okay, it may be a DB catalog, or it may be any REST catalog, or it may be any catalog. Okay, so I can implement based on what catalog that you are trying to implement. So in that case, what's the thing is, so according to runtime, okay, I'm not bothered about that implementation, underground implementation. Just I will pass only that name and version. You want to that blueprint in a certain location and return that location. Okay, that is nothing but string. So prepare blueprint. Okay, if you look into that, let me show that. Where is it? Okay, this is. So this is that API actually. Okay, this is a REST actually API. Okay, which receives a request. Okay, you could see that which receives execute and execution response, and this is the implementation. So you could see that handler, right? So this is a handler implementation. You could see that handler. The handler has to plug to the service controller, right? So it receives a request, right? So you could see that, process takes that input request and returns the response. So what it is trying to do, first, when it receives a request, it understands that what is the blueprint name and version. It takes a blueprint name and version it takes, and then uses the catalog service. Okay, uses the catalog service to retrieve that blueprint. Okay, prepare a blueprint. Okay, and finally we are getting a path, right? So this is a path. Okay, where we execute. And with that path, we are creating a blueprint runtime information. Runtime service, we are getting that. Okay, it's just nothing but request ID and passing the path. It creates all the content and relevant utility to access inside that. And finally, it is executing the graph by passing this runtime service. Okay, what is the catalog implementation? So if you look into that, it implements this one. So just I am right now for time being, I am returning that path. Okay, that path, it should be in the same path. So
okay,
there is a path.
Okay, the path we restored basically the decompressed version right now. Okay.
Okay, so how you are getting, that is the implementation comes here. That implementation comes here. Okay, so get the blueprint from the DB. So it means like associated database connection, database model, and JPA, and all those implementations will come to retrieve that blueprint file and extract in this particular location. Okay, that location is nothing but this location. Okay, which is nothing but deploy location. We should follow the naming convention. So it is nothing but deploy location / blueprint name / version. So you may have for a particular blueprint, you may have a n number of versions. So that's the reason blueprint name / version 1, 2, 3, 4. You can have that in number of versions. And based on once we get that request, okay, first we want to look at whether file is present in the particular location or not. If not, go to the database, download it, download it, extract it. Okay, that's functionality.
Okay. So the primary key basically is the blueprint name and the version, and that's right. Either if it's in directly we have a directory with the right name, right? Then we use it. If we don't, then we need to get it from the database, extract it, do the little processing here, and then okay, I get that.
Okay. Now with that blueprint base path, already we have utilities. Okay, so just let me go to the core and I will explain that. Okay, so we have already utility to extract from that, automatically read that information, blueprint information.
Yes.
So that it is available for you in during that operation. Now, inside the function also it will be there. Okay, so one good example is inside the Python. Okay, let me show that one functionality implementation. Okay. So you have that blueprint. See here, first step itself, we are checking the blueprint runtime service. So from that blueprint runtime service, you can get all the model information. Blueprint context holds that all the model APIs. Okay. So let me show that. Blueprint. So later I will come back. So it means like that blueprint runtime service is available for you, so that whatever the blueprint runtime service provides the API, it's available for you. So it means like you can resolve that node template, you can set a property there, you can retrieve a property there, you can get a file content, and all those, whatever the blueprint runtime services has, you can have that access with respect to the particular blueprint. So in that case, it provides all functionality to you. Okay. I think it's clear now.
It's extremely clear. Extremely clear. Thank you.
Now, so before that, let me little bit talk about that important core concept of runtime service and blueprint context, because that is a key thing here. Okay, so blueprint runtime and core service, already we have it here. Okay, we have a blueprint runtime service. Before that, let me tell that what is context. Okay, context is nothing but, okay, assume that you might have seen that XML context or visual context. Okay, in that it means like whatever the content model you are having as an instance actually. Okay, so it's like what are the file as a physical file. So you have as an instance, so that you can apply any APIs to retrieve those information. Say for an example. Okay, just in that example, I want to understand what are the workflows. So in that case, just with that context, you can .workflow. It will return that what are the workflows there. If I want to find a specific workflow, just workflow by name, by passing that name, I can get the workflow definition. And similarly for node type, data type. Okay, if I want to have that, so all utilities are defined here already. So it is very easy just by providing that path, okay, in that runtime service. Let me show the runtime service. Okay, blueprint runtime. Okay, so this is a blueprint runtime service. So you have, it is implemented as as an interface, defined as an interface, and then you have a default implementation below that. Okay, so here what you have a resolve node template property. So you don't want to write an utility to resolve that property. Okay, just you can resolve the property. Okay, similarly like set an input values or retrieve values or get input, get output, get node template property values and resolve property values, and all those things, all those utility, runtime utility. Okay, this is a static utility. Okay, blueprint context is a static utility. Static utility means only it talks about the model, and runtime it's like it talks about more on what data that we pass and what data we retrieve and what data stored and what data assigned. Okay, so all those things it talks about runtime. So for execution we need a blueprint runtime, and for validation we need a blueprint context, right? So you could see that all those implemented here. One good example is like a resolve node template property. So it means like you are just passing that node template name. So it has a resolve node template property implementation. So what it takes that, and finally it uses the definitions, and then it uses the context information, and then it resolves the property, and finally it returns a map. Okay, that assigned value. What is it? Similarly for operation input. Okay, and similarly for operation output. Okay, and then even for workflow inputs. Okay, so how it is stored. Okay, that all those things stored in a proper path structure. So all those paths, and it is clearly defined. And along with that, it provides extra utility such as get the property at runtime as a string, because everything by default, all the informations. Okay, whatever the information that we store, we are not storing an object. Okay, we are storing a JSON. Okay, so this entire platform, it's not to store any object and pass that object from one component to other component. Okay, because as I said earlier, everything we are going to operate in a data. Okay, we are not going to operate in an instance thing, and even handshaking between one component to another component, it should be a JSON. So that's the reason everything is defined as a JSON node. Okay, so you can't persist an object there. Okay. Or as well as retrieve that object. Okay, only the data you can persist and retrieve the data inside the blueprint runtime service. Okay, so everything is you can see it as a JSON node, right? So everything is a JSON, right? So that's the main purpose of blueprint runtime and blueprint validator. Everywhere you could see that blueprint runtime and blueprint validator in most of the locations, most of the places. And then we have a certain service like import service. Okay, import service to import in a blueprint. You might have noticed that. Okay, let me put that catalog. Okay, you might have noticed that it's the input at the top, right? So it has an import. Okay, 3 files. It has to be a part of that input. So to resolve this value, so we have an import service. Okay, which reads that import definitions and loads the context and uses that information, stores that information in the context. And blueprint expression. Okay, so if you look into the blueprint, we have a lot of expressions, right? So you all know that. Okay, we are using expressions. So one is a get artifact, it's one expression. Get input is one expression, and get property is another expression. And get attribute also we are going to support them. So these are all the expressions, right? So this expression, in order to have this expression, resolve this expression, we have a blueprint expression service, okay, which understands that expression and uses the runtime information to resolve that property. Okay, so it understands what kind of expression, and it executes, or it retrieves the value based on that expression and returns them, so that it provides all utilities. Okay, to resolve that expressions, to retrieve that expressions, and get the expression. Okay, and repo service. Okay, this is subject to change. Subject to change in terms of okay, we are having some blocking code here. So we want to remove that blocking code. Other than that, the structure is going to same, and we are going to simplify that repository. Okay, this is mainly used in terms of validation and as well as in terms of a local unit testing perspective. Okay, unit testing perspective, we don't want to use a database, okay, to retrieve that values each and every time. It is a costly in terms of time and in terms of resource perspective. So that's the reason we have defined that Blueprint repository service and implemented default file-based repo service. Okay, this is a file-based repo service, but in real service we are not using. Only for unit testing perspective, we are using a file-based service. And validator, as I explained that, okay, this is a common entry point. Okay, let me talk about little bit this validator. I think I explained that already. This validator, this is the one single huge validator. So you could see that 600 lines of code. So and more, we are expecting a lot more validation should come. That's the reason. So we are going to deprecate this validator, and we have implemented that validator as a separate definition. So you could see that all those validators are separate definitions. Okay, the same content is copied over here, and once we get that user story, once we work on that user story, we will deprecate this and switch that real validator to this validator. Okay, so we decompose that. Finally, what we are trying to do, we are trying to decompose this.
Britta, we have, like roughly, I would say, 9 minutes left. Could you maybe, because, the thing that we're kind of focusing right now is to be able to, upload and download and index, all, in the database, the CVA files. Maybe, since, the interface that we're using is kind of like, right now it's indicated as deprecated, maybe you could just go and show us, where, we should, add our, the interface that we have implemented, on a temporary branch, so, where we could, which REST API or which REST interface we should use for the purpose of actually doing this storage and retrieval, and probably providing also an index of the different like where we should implement the interface. And I believe that the actual storage, the actual database or storage, I would put it in the generic components, but you sort of mentioned that maybe they should go to the microservice. So anyways, maybe you could just take the last few minutes to kind of maybe explain this part. How do you see this, and how this should be done, to fit into the architecture that you came up with.
Okay. So we have the table already there. Okay, if you look into that, what are the tables that we use? Okay, so here is a place that where you could see that, and even we can modify this table also. Okay, it is not only to have a config name. Since AT&T, it's like
yes. Sorry, it's just yes, but this one kind of stores the blueprints already in the kind of decompressed version. We're talking about really the CVA files, like where we can put this. So we have to create a new table, as I understand, right?
I think you don't want to create a new table, just to modify that name, okay? Because
okay.
This is not going to change, right? So this one, it's not going to change. This the high level, it is not going to change, okay? Because
okay, but still we have to, because the CVA file contains everything, right? The config model only contains like right now I'm talking, right now.
Let me explain.
The blueprint portion of it, right?
Let me explain.
Like the definition. Okay, yes, okay, please.
Even I can take another 10 minutes also. That's not an issue. I will explain that. I can.
Oh, great, thank you.
I can be up to 3:45. So no issue. Okay. So see here. So we have a config model. So this is not going to change because high-level query has to happen in this config model. So it has the artifact name and it has a tags. Okay, tags. Okay, in a searchable query, because we don't want to have a query on real content, the binary content, which is very huge. So that's the reason we are managing in two different tables. One just to hold that information, and another one is just to hold that content actually. Okay, so for that, this table we are not going to change that as it is. We can reuse the same model. Only name we can change that. Instead of having that, we can have a blueprint model. Okay, we can have a blueprint model, and then here we can have a blueprint content. Okay, blueprint model content, we can have that. Okay. Now, so mostly what we are trying to use, we are trying to use an artifact name and version. I think we are using artifact version, and then artifact name, and then we are using artifact type, so SDNC model, something like that. So which SDC, I'm not yet Okay, we want to get that SDC annotation, and then we want to use that artifact type. And the rest of the things, it's like ASDC also, okay, which is relevant to ASDC, okay, so it has a distribution ID and all those things. So that's the reason we don't want to remove that. Still, we can retain as it is. And then only the informations, if you look into the table structure, okay, so right now the current Casablanca, okay, we store that service template as a content, right? You could see that long text. Okay, as a content we store as a JSON content. Okay, we store as a JSON content. Now we are going to convert this into binary. Okay, so what we are going to do, we are going to convert this into binary, and instead of having one-to-multiple relationship between these tables, okay, config model to config content, we are going to have one-to-one relationship. That's the only thing that we want to do. We want to have one-to-one relationship here, and then this content has to convert into binary content. So in that case, other than that, everything is the same, right? So in terms of storing, so this will be a binary content, zip content, entire zip it's stored here, and then it has a reference, one-to-one reference. And then whenever user queries on that, user queries on this high level, and when user wants to retrieve that content, then we can use a foreign key relationship to retrieve the content and transfer the content. And while saving also, whenever you get a request for a file to save, okay, so we can save that metadata information all here, and finally only the content information is there, right? So this is with respect to the JPA model and changes. So that's the reason. So you could see that model, JPA model domain. Okay, JPA model is in domain. In that domain only, you want to change that config model content. Okay, this one you want to change. Okay, so only instead of string, you should use a binary or blob.
Oh, and the whole CBA file should go there?
Okay, yeah.
Okay, good. So we don't need to decompose, because, right now we're we're kind of, expanding it to put it in the table, right? But now it's going to be the whole binary file. Okay, perfect, very good.
So there won't be much change, only that high level change. That's the reason only I annotated this deprecated, this field, it's the deprecated one. That's it. Okay. And other than that, I think, okay, and based on that, okay, now what's the thing is the repository also it is going to change, that content repository. Initially that content repository, okay, we use that, we used to store, okay, so we used to store with that content, right? Now it is going to store with the model. So based on that, okay, we are going to do some modifications here. Okay, it's like a binary storage API that we are going to implement, or sometimes it may be sufficient, sometimes it may not be sufficient. So whoever is trying to design, so they can take a decision, okay, what changes that we want to make it here. Okay, this is with respect to config repository, but model, with respect to model repository, there won't be any change. Okay, that model repository is plain simple. Okay, it's like high level repository. And even model search also it is not going to differ, and model type and resource dictionary also it is not going to differ. So rest other things it is going to be same. Okay, and coming to the rest, okay, so service template, you all know that service template validate, enrich, and everything, it works on a content. Now hereafter it is not going to work on a content, it is going to work on archive. So that is the reason. So it's the entire service template API itself it's going to deprecate, because okay, we are not passing a content. We are not going to pass a service template as it is. We are going to pass a zip content thing. So that's the reason it's the entire thing it is going to deprecate. And resource dictionary also on API and definition level there won't be any change. Only the change it is with respect to okay what kind of API that we are going to implement. It's like a Flux, whether we are going to use a web Flux or a router based mechanism. So what kind of implementation that we are going to have. So we are going to that with respect to that it is going to change. That's the reason it is annotated as deprecated. Still we want to follow with the REST controller pattern. Still we can use that. Okay, that is not an issue. And
so deprecated means that the current version is not it's not going to be maintained, but it's the same class will still be there, right? We just kind of modify it to fit the new requirements, right? That's what it means deprecated here, right? We don't have to ditch this altogether and re-implement it somewhere else, right? It's still here, just that a new scheme, right?
Exactly. It is.
That's what it means. Okay.
I think It is expected to change. That's what it means.
Okay, oh, that's what it means. Okay, because you see, that's I think that's what created a lot of confusion. Because especially, if you look at IntelliJ, the way it indicates when something is deprecated, it kind of shows a very violent strikeout, right? So that's why kind of I guess that all created all this confusion and misunderstanding that things were completely thrown away. But actually, it's not. It's just that it's an indication that major change is coming here. That's basically what it means.
Deprecation you can deprecate now itself or 1 year later or any point of time you can. Okay, but
excellent. Thank you.
It is going to change. That's a definition here. Okay. Coming back to that, okay. So we have a certain utilities. So this is which is a config model utility. It's a part of that utility, that old folder structure, old service template structure. So that's the reason we are going to deprecate that. Okay, and already we have that utilities already available there at the top, and mostly I'm done actually. So in terms of handling, only thing is like just think about like whether you can move this API to the common level. Okay, so I have defined that common, right? So in this application model common, I have defined that on API catalog API, right? So the catalog interface. So this catalog interface, okay, we can move to that commons actually, okay, under the core, components core, so that this interface can be used in both the places, okay. So prepare, because we need this functionality in both the places, okay, prepare, okay, for validations and as well as validation in terms of design time perspective, and as well as publish in design time perspective, and for runtime, it has to execute perspective in terms of executing perspective. Okay. So, one thing is like, let me see that whether I could move or whoever wants to work on that, then they can move this the blueprint catalog service to the component code, so that it will be available in the both, and each one will have its own implementation for that.